Hello guys, I'm Aryan, and today I woke up in the morning and saw a really interesting question on YouTube, and this was given by Indian School of Physics, which is a physics channel which uploads these kinds of problems, and it was a very interesting problem since when I read it, it highlighted envelope of projectile motion. So immediately I thought of safety parabola, which is a very rare concept which is actually taught to students. It wasn't taught to me, so if you have, you are a lucky person, I guess. But this problem basically had, I think, a 10-minute, I think, video solution, and it was very mathematical, incredibly. In like we had to write the range and then eliminate theta and then again d greater than 0. So it was a very mathematical problem, and with this concept of safety parabola, which I'm going to talk to you about today, it will be done under a minute. So this is a very good problem, I think, a little bit beyond the scopes of advance, but the concept of safety parabola isn't. So it is very important that you must know, and I'll be teaching that also. So let's start. First of all, what is a safety parabola? So when we write a standard projectile motion at an angle theta, and we fix the u velocity over here. So it can go in any angle theta, but with a fixed velocity u. So it can go like this, this, and so on. So all of these equations right here have an envelope, which I'm drawing with the red over here. One second. This envelope, and this is called the safety parabola. So this, all of the particles over here with projected at speed u will always be under this parabola, always at any angle theta. How is it derived? So there's a standard way of derivation which is also very lengthy, and I will show you a shorter way too. So you have to basically write the equation of trajectory, which is y is equal to x tan theta 1 minus x by r. Then we write r in forms of, r comes in form of 2 theta, right? So r is this u square sine 2 theta by g. So we write 2 theta in terms of tan theta again with this half angle formula, and then we make a quadratic in tan theta, and then we have to we do d greater than 0 for that quadratics because it exists for all theta, and then we get this equation of trajectory of safety parabola. So this is again very lengthy, and I will show you a much shorter way of doing it. So this question is actually first I'll show you this question. This was asked in both Pathfinder and Jalan the mechanics handout, where there's a rooftop over here with a slanted height, and this length is b and this whole length is c, and we are throwing a projectile from here with velocity u such that it touches all of these points, crosses and then lands over here with the absolute minimum velocity. So the answer of this comes out to be u square greater than g times a plus b plus c, which is a very, very important result. And with the help of this result, we'll be able to derive this equation of safety parabola in just under a minute. So basically how we'll do it. So you can think of this equation of trajectory another point of view, the minimum velocity to hit a point x comma y. So let's start from there. Suppose there's a point x comma y over here, and we have to find the minimum velocity u to hit this x comma y. And this is a very good question too, because most people over here will make this the maximum height of the projectile motion. Simply we write y is equal to ui square by 2g, and then they'll solve further from there. But this is not the case. This doesn't have to be the maximum height of the projectile for it to be the minimum velocity. So what we'll use this result right over here. Since this is true for all a, b and c, if I limit a to 0, if I write this limit a to 0, this will just become u square g times b plus c. And what will this look like? This will basically look like this a almost negligible, b and then c. And if we consider this the point of origin, we have to basically find the minimum velocity to hit this point, right? This is x comma y and x comma y, and this is b over here, which is just, and this is the origin. So this will be just root of x square plus y square, and this will just be y. So the minimum velocity will come to be y plus root of x square plus y square. And this is the equation of safety parabola. And I know it seems a little weird like this, but when you arrange it, when you do this is equal to x square plus y square, and when you arrange it, y square gets cancelled, we get this u square by g square minus 2 u square y by g is equal to x square. This, and we again rearrange it in terms of y, so I'll just do that over here. We get 2g square x square by 2u square. I think this is, yeah, is equal to y. I think this is the, yes, this is the equation of safety parabola. And we can use this result. You don't have to remember it like this, okay? You don't even have to remember it like this. Simply just remember this result. This is very important, and advanced has not touched this concept right here. I mean, in all of the PYQs of kinematics and projectile motion, this has not been asked yet, and seeing the increasing level of difficulty in all of these years, this can be asked, and this is a very important concept. So please note this in your book or wherever you want, but please remember this, and then you can derive it onwards later on. It is not will come in one line. You just have to do a little bit of manipulation. So we get this equation over here, which is the equation of safety parabola. Once again, let me just check if I have written correctly. One second. Yes, this is the equation of the safety parabola right over here. So again, I've derived it in the same way. I've not written over here, but same this equation comes. So let's move on to the previous problem that we had, which was given to us by Indian School of Physics. It's a very good channel, and a complete credit goes to them that they gave this question. I think it was a original question framed by them. So let's move on to this question over here. So what they are asking is, we have a disk over here rotating with omega naught angular velocity with radius r, and each particle from here is getting projected with omega r velocity. Since it's tangential and there's no translation, so the velocity will be u is equal to omega r, and all of these particles are being projected at any angle. Suppose this one is 90, this one is some theta, again some phi, and these all are coming under the safety parabola, and we have to find the equation of safety parabola. So what you have to understand is over here that we had used this point of origin. I mean, in standard projectile, this was the point of origin, but over here this is. So the equation will come in the same manner, which was y is equal to u square by 2g minus gx square upon 2u square. I think this was the equation, if I'm not wrong. It will come in the same manner, just we'll add a constant c to it, since we are shifting the origin. And now why I'm doing this in mathematics, what we usually do is we shift capital X to x minus mh and y is equal to y minus mk. So why I'm not doing this over here, because when I shift this to this, we are getting x as r sine theta, r cos theta, and y as r sine theta, and we don't want the equation to have theta in it, because what they have derived it is by this only, and then they have eliminated theta by squaring and adding it, and then they have done d greater than 0, and we don't want to do that again. So I'm just using plus c over here, because the equation will come in the same format. So when I write plus c over here, how do I find the c? So basically just take, how do you do it? Just take this point, for example. This will have vertical, since the angle is over 90 over here, this will have vertical velocity omega r. And what will be the maximum height when this touches the safety parabola? What will be the maximum height over here? It's uy square by 2g. Uy is just omega r, so omega r the whole square by 2g. This will be the maximum height. So the point minus r comma omega r square comma 2g, this will satisfy our equation over here. So we'll simply satisfy it. Y was omega, I'm just writing u and then I'll replace it final with omega. So u square by 2g is equal to square by 2g minus g minus r the whole square. So 2g plus c. So this gets cancelled and we get c g r square by 2g square. Simply we get c over here. And then we substitute it over here, and that is the final answer. And we write u is equal to omega r, obviously. So u is equal to omega square r square by 2g minus g x square by 2 omega square r square plus gr square by 2 u square. This is the final, so omega square r square, and then this gets cut. So this is the final result, which matches with the answer they have given in the video. And I just wanted to share this with you that this was a very good problem, and also the concept of safety parabola is very important for such type of questions. And see how quickly we didn't have to even write theta over here, because we knew the equation of standard safety parabola, or the envelope of safety, whatever. So we get this as the answer, and this was a very good problem, and full credit goes to Indian School of Physics for giving this. And if you want to see such interesting or new conceptual problems, so you can let me know. I have some of them over here also. Suppose this is also very interesting. It was based on the question that came in advanced 2025, but instead of a ring, basically they have an ellipse over here. So how will it change? Nothing much, but I have some good questions, and if this gets enough attention, and if I have some time, I will share it with you all as well. So thank you everyone. Bye.